this video for Computer Science 9618 AS level, we'll be taking a look at paper 2 questions, a medley, an assortment of questions. Yes, problem solving and writing algorithms is on paper 2, but there's also other paper 2 questions and topics you'll need to know. Let's go ahead and take a look at these medley of questions. The first one deals with errors. Now there are 3 types of errors. There are syntax errors, the second is runtime errors, and the third are logical errors. These are in no particular order. So let's take a look at the question and then apply these. Sylvia is testing a program that has been written by her colleague. Her colleague tells her that the program does not contain any syntax errors. State what her colleague means by does not contain any syntax errors. So basically they're asking, do you know what a syntax error is? And if there are no syntax errors, that means there's no reserved word that in the program is spelled wrong. These are if, then, end if, select, case, dim, integer, string, character. None of those are spelled wrong. It can be compiled or interpreted, meaning the program can actually run. It also conforms to the rules of grammar of the high-level language. Then it says identify and describe one other type of error that the program may contain. So we can choose runtime or we can choose logical. So you can choose either one of these, you just have to explain them. So for a logical error, the program does not give the expected output. A logical error is the error on the programmer's part. Our program runs, it compiles, we can give input, but the output we get isn't what is expected. It doesn't work the way we intend it to work. That is what we mean by a logic error. And then for a runtime error, the program crashes due to an illegal operation or gets stuck in an infinite loop. When we say an illegal operation, we mean trying to divide by 0, which is not allowed. Let's take a look at the next topic. Data types are a popular question that comes up on paper 2, because remember, paper 2 is about problem solving and programming, writing algorithms, and one way to do that is to be familiar with data types. Now there are specific data types you want to be familiar with and you want to know how to use these. They are strings, which is just a string of characters. It can be letters, numbers, symbols, or a combination of. Integers, which are your whole numbers without a fractional part. Then we have character. Now a character is different from a string because it holds one symbol, one character. It can be a number, can be a letter, or it can be a symbol. Now, we want to point out when we're talking about numbers as a character or a string, a character 5 is not equivalent to the number 5. A string 57 is not equivalent to the number 57. So it's important to know that. Strings and characters work off the ASCII code value, not the denary value. Boolean is another one you'll need to be familiar with. Those are our true or false operations. Real numbers are your decimals. So if you're programming in VB, you know these are your decimal data types. If you're programming in Java, these are your double data types. And then the last one you need to be familiar with is the date data type. And we'll be talking about that a little later. So it says complete the following table by giving the appropriate data type in each case. They're going to give us 4 points for this question. The first one says the average mark in a class of 40 students. If we're getting the average, more than likely it's not going to be a whole number. I know it's going to be a decimal. That's going to be the real data type. And that means real number, which is any number with a fractional or decimal part. An email address. Well, I know an email address could be numbers, could have letters in it, also has that @ symbol. So I can't use an integer here because it may contain letters. I know right away that's going to be a string. What about the number of students in the class? Well, you can't have half a student. That's going to be an integer. It's going to be a whole number. And then to indicate whether an email has been read, it either has or it has not. Because there's only one of 2 options, that's going to be a Boolean. True that it has been read, or false, it has not been read. Let's take a look at the next part, which is all about algorithm design, specifically what we need. So here it says an airline wants to provide passengers with information about individual flights and allow them to book their flight using an online booking system. Tick one box in each row of the table to indicate whether each item of information would be essential for the customer when making the booking. So in other words, what do we need to know in order to book a flight? So the first one is departure time. Now, when designing a program or algorithm, we need to figure out what we need, what information is relevant and required for our program. Does it help us book our flight online? Departure time. Does that help us book our flight online? Do we need to know the departure time? Of course we do. What are we supposed to do? Buy a ticket, show up at the airport, hope we get there at the right time? No, we definitely need to know the departure time. What about flight number? Does that affect departure time? Does that affect the airport, the aircraft type, the ticket price, the number of seats? No, it doesn't. That doesn't affect anything. The flight number is not essential in me booking the airline ticket. Now, when I get to the airport, I definitely need to know my flight number so I get to the right gate and get on the right plane. But this is not about getting onto the plane. This is about making a booking online. So when you come across these questions, you just want to slow down a little bit and think through it. What about departure airport? Is that important? Absolutely. I need to know where I'm departing from. If I buy a ticket and find out I have to fly out of New York International Airport, I got to go up several states to do that. That's like a 24-hour drive from where I am. I'm not going to drive 24 hours to the airport. Then what about the aircraft type? That's not essential. It doesn't matter I know I'm getting on a plane, but the aircraft type does not matter. It's not going to help me book my ticket. What about the ticket price? Definitely need to know that. Maybe I'm only willing to spend a certain amount of money. So I need to make sure I'm staying within my budget. I don't want to buy a ticket if I don't know how much it costs and then realize I've been charged, $2,000 for a first class ticket that I may not be able to afford. What about the number of seats in an aircraft? Does that have anything to do with my booking? Absolutely not. Review this and we'll move on to the next question. We're going to continue using that information from the flight booking system for this question, which is about abstraction and problem solving. Now, there are some terms you're going to need to know for paper 2. The first one, of course, is abstraction. That's what this question is talking about. Another term they could ask you about is decomposition. Now, this is breaking a complex problem into smaller parts. Algorithm, ordered set of steps to follow for a given task. This is something you've been designing or hopefully have been designing all year. When you write code, you're writing a ordered set of steps to solve a given problem, and then stepwise refinement. This sounds very similar to decomposition, but it's not the same thing. And on the next slide, I'm going to go over the difference between the two. But let's go ahead and take a look at this question. Identify the technique used to filter out information that is not essential when designing the booking system and state one benefit. I don't need to know the flight number. I don't need to know the number of seats. All of that information is useless to me. When I get rid of that, we call that abstraction. It gets rid of useless information. That is a very simple benefit. The other benefit, though, by getting rid of useless information, we make the program simpler to write. It increases the speed of design because we have to spend less time because we're only coding for the things we need. We don't need to code for the flight number. That serves no purpose. So we're able to leave the things out that we don't need. It also makes it easy for the user to use the program. Then it says identify 2 additional pieces of essential information that a passenger might need when booking a flight. And this is where the problem solving comes in. There's nothing you can do other than to think critically and ask yourself, okay, what else would a passenger need to know when they're booking their flight? Well, the first one is the destination. We have the departure, but we need to know where are we going. We need to know where you are going so we can make sure you go where you want to go. I don't want to buy a random flight and end up in some random city. The next thing I need to know is my arrival time at the destination. I need to know when I get there. We need to know that information. If I'm arriving at 11 o'clock at night, I need to know, hey, can a family member come pick me up? Do I need to take an Uber or whatever it may be? Let's take a look at the next question. And going over decomposition and stepwise refinement, we need to distinguish between the two. Now, when you have a complex problem, you first want to break it down into smaller and more manageable parts. Now, an example of that would be checking the win for tic-tac-toe. You can put that in a custom procedure or a function and just call it repeatedly. How you check the win for tic-tac-toe has nothing to do with how you play tic-tac-toe. You're just checking to see if there are 3 X's or O's in a row in the various configurations. Now, when we break it down into smaller, more manageable parts, we call that decomposition. Now, once you have it in more manageable parts, you've done the decomposition, the next part is to write the steps as a statement in a high-level language, and that is stepwise refinement. So it should be broken down into more manageable parts. That is the decomposition portion, and then we need to be able to understand it so it can be programmed, and that is stepwise refinement, and we call that the top-down design. All right, so here's a question about stepwise refinement and some bonus data type questions. So it says, explain the purpose of stepwise refinement. Well, it's to split a complex problem into smaller parts so it's easier to understand. The smaller parts should now be able to be programmed by the programmer. Then we have some data type questions. Programming languages support different data types. These usually include string and real. Complete the table by giving 4 other data types and an example data value for each. It's very important you read that because you may say, oh, they want the definition. They give you these huge boxes for the example data value, and if you're just going through the test, which is a high stress situation, you may think they want the definition. That's not what they want at all. The first one I chose, and you can put these in any order, is an integer. Now, an integer is a whole number. I chose the number 47. 47 is not in quotes, single or double, because it's a denary value. If I put it in quotes, that's no longer an integer. That's a string. So we got to make sure it's not in quotes at all. There's nothing that goes around it. It's simply a whole number. Then we have a Boolean. You have 2 options to choose from. You can choose true or you can choose false. I chose true. For my third data type, I chose char, which stands for character. Now, a character is different than a string. A string has double quotes. A character has single quotes. I chose the @ symbol and I put single quotes around it. If I put double quotes around it, I'm going to lose that point from Cambridge because they're going to say, that's not a character, that's a string. So when you use a character, make sure it's single quotes and the data type is char, not the full word character. The last one I chose is date, and I chose date for this format. Now I chose the 22nd day of March 1996. Now here's why I chose date. It's to help out my students, because remember, the date in the UK follows the day, month, year format, not the month, day, year format like we do here in the States. Now, if you're in a different country outside the UK and outside the United States, you may already follow the day, month, year format. If so, you're good to go. But here in the States, we don't follow that. And I have to remind my students every year, Cambridge follows the day, month, year format. So if you have to write a date like we did here, we have to make sure that it makes sense. If I do March 22nd, like 3/22, they're going to mark it wrong because they're going to say there is no 22 or 22nd month of the year. So you definitely want to look out for that. Let's take a look at the next question. All right, getting to abstract data types. Now, these are the ones you need to know. You need to know Q. This means it uses the first in, first out principle. Stack is the last in, first out principle. And you need to know linked list. It is straight from the syllabus. Now, you're not going to be required to write pseudocode, but you should be able to add, edit, and delete data from these structures. And that's what these questions go over. Remember, Paper 2 is a lot of writing algorithm designs, but it's also knowing how to use various types of algorithms such as abstract data types, and that's why we're going over all of this inside this video, because we've done lots of problem solving ones. There are other videos out there that talk about how to solve those problems, but I'm trying to help you as much as I can by touching on the things that you may not have touched on. So, abstract data types is one. So it says the diagram below shows a Q. The front of Q pointer points to the next item to be removed. That's how a queue works. The first item in, that's going to be the first item out of the queue. The end of queue pointer points to the last item added. Because elk was the last one added, it's going to be the last one to leave. The queue is circular. What does that mean? Well, that means when I get to index or location 7, I can swing back around, adjust my pointers, and use any of the other locations that are currently not part of the queue. When I remove frog, I don't actually delete it from this array here. I'm going to leave it there. I'm just going to adjust my front of queue pointer. So it says, describe how octopus is added to the given queue. Well, I know it's going to go to location 4 because locations 0 to 3 are being used. Now, I need to adjust the end of queue pointer because the end of the queue isn't going to continue pointing to elk. I just added octopus. So the end of queue pointer is then moved to point at octopus or location 4, showing it is now at the end of the queue. I went ahead and updated that. So if you're wondering where do those 2 points come from, you're showing that it gets stored at location 4 and that end of queue pointer is updated. Describe how the next item in the given queue is removed and stored in the variable animal name. For queues, you have to remember the first one in is the first one out. Now, the first one in was frog, so we're going to be removing that. It works just like a standard queue does at a theme park. You get in line. The first person in line is the first person out of the line to get onto the ride or whatever it may be. Well, the front of queue pointer is used to show the location of the next animal to be removed from the queue. Right now it's pointing at location 0. The data at location 0 frog is going to be loaded into animal name. Then it says describe the state of the queue when the front of queue and the end of queue pointers have the exact same value when they are equal. I'm showing the next item to be removed. That's the front of my queue. If the end of the queue is the same value as the next item to be removed, it's also the end of the queue. That means when there's exactly one item left, it's showing it starts at this location, but also ends at this location. So when you see that they're equal, it means that they have one item left. Now, you'll need to adjust the front and end of queue pointers. So it says some operations are carried out on the original queue. So here we have the original queue they gave us with the original pointers. It says complete the diagram to show the state of the queue after the following operations. So they want us to add wasp. Remember, with queues, an item is added, the end of the queue pointer is adjusted. When an item is removed, the front of queue pointer is adjusted. So we need to know that. We add wasp. We need to adjust the end of queue pointer. So I adjust it, I move it down. It's now pointing at location 4. But then they want me to add B. So I add B, I adjust my end of queue pointer. Then we want to add mouse. I add mouse. And now that I'm done with the question, I show the final position for my end of queue pointer. So I have my front of queue, which is pointing at frog. And then I have my end of queue pointer at location 6 showing mouse. Wasp goes in first, followed by B and mouse. And then it says, but remove 2 data items. Well, if I'm going to remove 2 data items, that's going to be frog followed by cat. If frog and cat are no longer part of my queue because I moved them, I need to adjust my front of queue pointer, which is now looking at fish. Now the question is done. I've added wasp, bee, and mouse in the correct order. I show my final front of queue pointer and my final end of queue pointer. Let's take a look at another part of a queue question. Okay, this one can be a little tricky. It shows the state of the queue after other operations are carried out as shown. So here we have the front of queue pointer, we had the end of queue pointer. Doesn't match up exact. I think it does match up where we were. Ours was at fish. So there are more operations carried out that adjust that front of queue pointer. Complete the following diagram to show the state of the queue after the following operations. We want to remove one item. And then we want to add dolphin and shark. And this is where the wraparound comes into play. So I ask myself, before I get down here to get the answer, how did I get that? Well, what's in the queue currently when I look at the queue that was given to me? Well, elk to moose, locations 3 to 6 are in my queue. That means location 7, 0, 1, and 2 are not part of my queue. Now it says I want to remove one item. When I remove one item, I'm going to change my front of queue pointer from 3 to location 4 because wasp came in after elk. That's the next item to be removed. But it wants me to add dolphin and shark. Well, the bee and the mouse are part of my queue. The next location I can use is location 7. I'm going to overwrite ants and I'm going to put dolphin. Because it's a circular queue, I can circle back around and overwrite things that haven't been used. And the next location is frog, and I'm going to put a shark there. Cat and fish will stay there, but now my front queue starts at wasp. I have wasp, bee, mouse, dolphin, just like I had in my original queue, except for I overwrote ant because that's no longer needed. It circles back around and ends at shark. I didn't put cat, fish, or elk back in my queue. And you may be saying, well, here, elk was the front of queue pointer. Yes, I'm aware of that, but remember, it said remove one item, so we had to adjust that front of queue pointer. So when we add an item, we add it to the location after the end of queue pointer. When we add it to index 7, we move it to the next location, which is back around to location 0. Then it says the queue is implemented using a 1D array. Describe the algorithm that should be used to modify the end of queue pointer when adding an item to the queue. Your algorithm should detect any potential error conditions. So in paper 4, you may actually have to code out a queue using a 1D array. Now, if you're retaking paper 1 and 2 and you have paper 3 and 4 to take, I do have videos that walk you through how to code a 1D array. This question assesses your knowledge of how queues actually work, because remember, that's part of the syllabus that I mentioned earlier. So when an item is added to the queue, the end of queue pointer should increment by 1. If an item is added and we are at the last location of the queue, it should wrap back around if it's a circular queue. We cannot add to the queue if it is full. This is the potential error condition. Now, this is done by seeing if when we add an item, the start of the queue is the same as the end of the queue. If that is the case, when we add the item, if the start and end come out to the same place, there's no more room. It is full. Because remember, when we add an item, the end of queue pointer increments. So here, if I'm at 7 and I add an item, let's say my front of queue pointer is at 0. So like down here. If I add in my end of queue pointer, let's see, I want to say this, because let's say the front of queue pointer is at 0. The end of queue pointer is at 7. If I add an item, it swings around back to index 0 because the end of queue pointer is going to increment. It's going to go to the next location. Because this is a circular queue, it's going to swing back around to 0. Now the end of the queue and the front of the queue pointer are exactly the same. Well, because they're the same, that means the stack is full. I want to check for that and then say, hey, you can't add it. It is full. And if you watch that paper 4 video, you'll see how it works. Now, for paper 2, you don't need to write code, but you will need to do it in A level. Let's take a look at test data. A program controls the heating system in a sports hall. Part of the program involves reading a value from a sensor. The sensor produces a numeric value that represents the temperature. The value is an integer, which should be in the range 0 to 40 inclusive. A program function has been written to validate the users from the sensor. Now, when you look at the mark scheme, I'm almost positive the mark scheme is incorrect. I think whoever wrote the mark scheme mixed up extreme and boundary testing, and we're going to go over all of these. So you need to know these 4 types of test data. You need to know normal, and that's within the given range. If I say 0 to 40 inclusive, 23 is normal data. There's nothing crazy about it. But there's also abnormal, there's extreme, and there's boundary testing. Now, when you look at Cambridge's answers, their mark scheme, remember, it is a sample mark scheme. It is the one that was early released. The real mark schemes are a lot thicker and they have a lot more detail to them, and they do not give those out to the general public. When you look at the definitions, you'll see that their answers don't always match up with the mark scheme. So I'm pretty sure Cambridge has mixed this up. I could ask Cambridge about it, but we always get the same response. We're not allowed to talk about mark schemes. That is their official response. And they're humans. Sometimes they're going to mess things up. It's not the end of the world. All you need to do is know your stuff. And when they see a lot of students mark an answer that they don't have, they're going to say, hey, wait a minute. We need to investigate this further. So the test data, normal. This is to be accepted by a program. It's used to show that it's working. Abnormal test data should be rejected as it is unsuitable or may cause problems. This would be like, oh, we need to enter a number. I'm going to go ahead and enter a letter. That's abnormal test data. It's unsuitable. It's not going to take it. It's going to cause me problems. The program is going to crash. Then there's extreme data. Now, on the high and low end of what is accepted. Now, in this problem, 0 is the low end, 40 is the high end. That is extreme test data. Cambridge labeled it as boundary test data. The boundary test data is on the high and low end of what is accepted and right below it and right above it. So for boundary test data, we don't want to test just 0. That's extreme test data. We want to test 0 and -1 for the low end. We want to test 40 and 41 for the high end. That is boundary test data. So make sure you know that. All right, let's take a look at state transition diagrams. A program module controls the heaters. This module operates as follows. If the temperature is below 10 degrees, switch the heaters on. If the temperature is above 20, switch the heaters off. Now, they've already given us a start point, so that's fine. So make sure you label start if they haven't done it already. Now, there are states and there are events. Events change the state. You may have to fill in either the states or the events. In this case, we have to do the events that change the current state. So here I start. The heater is off. How do I get the heater to turn on? If the temperature is below 10 degrees. So if the temperature is less than 10, the heater is going to turn on. Now let's do this arrow right here. If the heater is on, what is the condition for the heater to stay on? Well, how do we shut it off? If the temperature gets above 20, we're going to shut it off. So as long as the temperature is less than or equal to 20, that heater is going to stay on. Now, how do I get from the heater on to the heater off? It says if the temperature is above 20, switch the heater off. So if the temperature is greater than 20, I'm going to shut that heater off. And the last thing I need to do is fill in this circle. If the heater is off, how do I keep the heater off? And that is if the temperature is greater than or equal to 10, because the only way it's going to turn on is if the temperature falls less than 10 degrees. Let's take a look at the next section of questions. This next part is about subroutines, which are custom procedures or functions. So you need to know what the purpose, and the purpose is to reuse code. Remember, the programs are going to be broken down in simpler or more manageable parts. Testing is easier to be done. Maintenance is also easier. So state 2 reasons why the programmer may decide to use a subroutine. Well, when code that performs a specific task needs to be used multiple times and called different places in the program, like a check win for tic-tac-toe. We're not going to put that check win condition in every single place. We're going to put it in a custom procedure, and we're simply going to make a call to that procedure throughout the program. It's also easier to update, debug, and test a smaller section of code since it has been broken down into smaller parts. So these are all the parts right here. You can choose any that you want to do. So that's the purpose of having subroutines. Now, arguments and parameters. A lot of people say these are the same thing. They are not the same thing, and they're used all the time interchangeably by beginning programmers. They're not the same thing. Arguments are values being passed to the procedure or function you're calling. Parameters are values being accepted by the procedure or function, like in this case. So here we have count as an integer, message as a string. Because those are the values being accepted, we call these parameters. And it is to pass values, which are the arguments. Now, arguments is spelled with one A, not two, so that's a typo, no big deal. To pass values, the arguments from the procedure or function, calling myproc, which is the procedure we have here, to the parameters count and message. So it's very important you know the difference between arguments and parameters. Now there is testing as well that could show up on our exam. The algorithm in part A is part of a program that will be sold to the public. All the software errors that were identified during in-house testing have been corrected. Identify and describe the additional test stage that may be carried out before the program is sold to the public. With testing, there are four stages, but there's also various types of testing. There's white box, there's black box, there's integration testing, which also includes stub testing. Now, stub testing is when you call a dummy module. What does that mean? That means you're calling a procedure or function that has no code in it. That's just because you know somebody else is writing the procedure or function. You know you're going to need to call it later. You're going to go ahead and call it, and you want your program to compile, so you're going to call a procedure or function that is empty that will be filled in later by a different team member. There's also alpha testing. This is the in-house testing. This is done by the programmers. It says right here, in-house testing. Following alpha testing is beta testing, followed by acceptance testing. So because in-house testing has already been done, we know the next stage is beta testing. Testing is done by a small group of individuals. This testing done by the users makes sure the program works as intended and there are no errors. Anytime they release a demo or an open beta for a video game, you are part of beta testing. You're like, wow, we get to play the game for free. Well, yes, but you're also working for that company for free because you're testing it, making sure it works as intended. Any problems that are found are addressed before it's released and sold to the public. So if they find that one weapon is really overpowerful in a first-person shooter, they may adjust that so it balances out. Now, if you're Bethesda, you don't need to worry about errors. That's just part of the game experience. It's not a bug, it's a feature. You know, Bethesda, they see errors and they're like, oh, we'll just leave it there because that's part of the game experience. Now, evaluating code. So here is another way they could ask you to evaluate code. Very simple, but a little tricky at first. So part of an identifier table is shown. Make sure you understand how to use string manipulation left. Here, in this one, they use mid, but they could use left. They could use right. They could use mid, which they did in this case. You also want to know what this int means. It means converting to an integer or casting to an integer. You need to know what length is. You need to know those Boolean operators. So you want to program using these over and over. You want to try a lot of different things. And when you are in doubt, refer to the insert. You're going to be given an insert. It's the very last page in your exam. You want to have that handy. If you don't have an insert, you need to let your examiner know that you need one, because when you're in a high stress situation, it can cloud your thinking, it can cloud your judgment. You may be second guessing yourself. Well, just refer to the insert. Take 30 seconds, refer to the insert, remove that doubt, and get your confidence back and get rolling. All right, so let's take a look at this. Mid. We know mid works starting at character 1, not index 0. So it wants us to get the mid of char list. So mid is a string manipulation one. Then we have the starting point, which is month, flag, day, and then we want 1. So I'm looking here. I'm looking inside these quotes. I'm looking at character list. Now this is a string because it has double quotes. Remember, characters have single quotes. So I need to make sure I put that inside my answer because I'm only going to have 1. So I look at my char list, okay? A, B, C, D, E, F. Then I want month, flag day. So I look at the flag day. What is the month of flag day? 4. How many characters do I want from that location? 1. So I count the characters. A is not 0. A is 1. So I do 1, 2, 3, 4, which is D. Starting from D, how many characters do I want? I want 1. single quotes here because it is a character, not a string. Now, here we have int. This means we need to do this calculation and then we need to convert it to an integer or cast it to an integer. So count. I take a look at count. That is 29. 29 divided by the length of char list. The length is 1, 2, 3, 4, 5, 6. It is 6 characters long. What is 29 divided by 4? Well, that is going to come out to 4 because 29, no, divided by 6, not divided by 4. It's like, that's not right. 29 divided by 6 comes out to roughly 4.7, 4.8, somewhere around there. But it's converting to an int. What does that do? We just chop the decimal off. We don't round up, we don't round down, we simply chop the decimal off. So we get roughly 4.7, 4.8, chop that decimal off because we're converting it to an integer and we're good to go. And again, that is 29 divided by 6, not divided by 4. When we do 29 divided by 4, I was like, something doesn't look right. So 29 divided by 6, and then we get 4 point something. All right. For this one, the key word is and. Count is greater than or equal to 29. That is true. So here we have true, and the day of Flag Day is 23, is greater than 23. Is 23 greater than 23? No, it is not. What happens when I put true through an AND gate with false? It comes out to false because the AND rule is both must be true. Let's take a look at the next set of questions. Structured English is another thing they could ask you about to problem solve. So it's here it says an algorithm will process data from a test taken by a group of students. The algorithm will prompt and input the name and test mark for each of the 35 students. The algorithm will add the names of all the students with a test mark of less than 20 to an existing text file support list, which already contains data from other group tests. So structured English. It's simply steps used to solve a problem using an agreed subset of English words for commands and mathematical operations to represent the solution. That is the definition from Cambridge, and they move right on to the next part, not really spending a lot of time talking about it. So we're going to go through this example. So here it says, which already contains data from other group tests. We don't want to override it. We want to simply open that file. What do we want to open it for? We want to open it to append that file. And we want to use the word append. Append means we are updating the file. Step 2, we want to prompt for student name and mark, have them input their name and mark. All I'm doing is using structured English, not using high-level languages, just simply saying I want to prompt for the student name, I want to prompt for the mark, I'm going to have them input their name and mark. Now, if the mark is greater than or equal to 20, I'm going to jump right to step 5, which I'll get to in a minute, because step 4, if it's not greater than or equal to 20, I want to write the name to the file. Now, I don't want to write the score. Notice it says right here, the algorithm will add the names of all the students. Doesn't say it will add their test marks. So we can't simply say write data to the file. We have to say write the name to the file. And then step 5, I want to repeat step 2 35 times because there are 35 students. Now, you may be saying, well, that's it and we're good to go. Do not forget, anytime you open a file, you also need to close the file. So make sure you don't forget about that. Now, continuing with files, you can do 3 things with a file. You can read, you can write, and you can append. So why is it better to store the names of students in a file rather than in an array? Well, you can store the data even after the program is closed. If I write to the file, I have that data. If I just have it in an array, as soon as I close that program, it's gone. But if I have it in a file, I have it. I don't need to re-enter the data every time my program starts. And then why is write mode not used? Why does append have to be used? Because when you're using that, when you're writing code and you're opening a file to write, all existing data is erased. It's creating that file for the first time, or the second or third time. It's getting rid of all that data that's there. Now, append allows the data that is currently in the file not to be erased. You're simply adding the data to the existing file, not overwriting the contents. Now, here's an alternative state transition diagram question. So you need to identify the inputs, the states, and the outputs. So you need to be able to read an existing complete state transition diagram. So here they've done the first row for us, which is the start state. There's no input or output. We're starting at state 1. Now, if I'm at state 1, they give me input A. Well, I look here. Here's input B. That's not going to work. Here's input A, but that's going from state 4 to state 1. I have to go from state 1 to somewhere else. Here's input A, output X. I end up at state 2. So my output is right here. It tells us it's X. What's the next state? S2. Now that I'm in S2, they give me the next state, S2. There's something that happens in S2 that causes me to stay at state 2. Well, what's the input? I look right here. My input is A because I want to stay at state 2. What about the output? There's no output. There's no output word, so I simply write no output. I would not leave it blank. If you leave it blank, they may not give you the benefit of doubt. They may say, they didn't know what to write there. So I'd write no output or show indication that there is no output. Now, the next part, they don't give us the input or the next state, but they do say output W. If I'm at state 2, what is output W? What's the input? The input is B. What state do I arrive in? I arrive in state 3. Then it gives me the next one, output W. Well, that's not going to be here because this is input B. Here's output W. Where does this take me? It takes me to state 4. What's the input? The input is A, the output is W, and I end up in state 4. That's another way they could ask you state transition diagram questions. Now, another abstract data type you need to be familiar with is the linked list. Now, it has pointers and uses pointers, so data does not need to be in order. You can put everybody in alphabetical order in an array by having them out of order, but using pointers to point to the next item. And the next item is pointed to by the current item or index that you are at. So it says a stack is used in a program to store string data, which needs to be accessed in several modules. A stack is an example of an abstract data type. Identify one other example. Now we've already done queues, so I wanted to do a linked list. Now you do have to program one in A level. Again, if you need help doing that, I have a video that walks you through all the steps of programming a linked list with a set of test data so you can understand it, and I'll walk you through all of that. So if you're going to need that video, make sure to be on the lookout for that because it is currently live. So the example we're talking about is a linked list. Now each node, which is each index, contains data and a pointer to the next node in the linked list. Now the list has a start pointer, so you know where to start because it may not start at index 0. The first person in alphabetical order may be in the middle of the array. So we need to know where we're starting. And the last item has a null pointer, meaning we've reached the end of the list because the last item isn't going to point to anything. So we give it a null pointer. Now when a node is added, data in the array does not need to be reorganized. The pointers are simply updated when an item is added. Now, nodes are traversed from one element to the next by use of their pointers. Let's take a look at the next set of questions and get ready to wrap this up. Our last topic to wrap up this medley is about the last abstract data type you need to know, which are stacks. They work on the last in, first out principle. That means the item that was most recently added, that's going to be the first one to go. It does have a pointer, which we call a stack pointer. So it says, explain how the stack can be implemented. Well, we're going to declare a 1D array as string with the size of the array corresponding to the size of the stack. Now, each item in the array is going to correspond to a single index. We have a stack pointer that's going to be declared as an integer and used to reference the most recent item added to the stack. Now, each time an item is added to the stack, we want to increment the stack pointer to point to the most recent item. Now, this is called a push. We're pushing it. So when an item, which is the most recent item, is removed, we pop that item. So we have pushes, we have popping. So from the stack. Now the stack pointer is decremented to account for this, pointing to the next most recent item. Now here's an example of a stack. So we're going to walk through this one. So a second stack is used in the program. The diagram below shows the initial state of this stack. So that's right over here on the left-hand side. Went ahead and copied it right over here because after we do group 1's code, it's going to need to be updated. Uppercase letters are used to represent different data values. Stack operations are performed in 3 groups as follows. Complete the diagram to show the state of the stack after each group has been performed. So the first thing they want us to do is push D. I push D, which means add D, directly to the stack. It goes right on top. Then it says to push E. That goes right on top. The next thing I need to do is I need to show my stack pointer. What item was most recently added to the stack? That was E. Group 1 is done. That's all you do. Now for group 2, it says to pop, pop, pop. So we're going to pop 3 items. We're going to pop E, we're going to pop D, and we're going to pop X. So I have P, Z, Y, X. I have D, E. Here's my stack pointer. But remember, I popped it. I'm going to lock it in and drop it. So that's all we do. So E, D, X were removed. My stack pointer is now at Y. So they want us to push A, push B, pop, and then push C. So I have P, Z, and Y. Now, X, D, and E have been popped. They're still inside my array. It's my stack pointer that points to the next item. So now they want me to push A. So I'm going to add A onto my stack. Then it wants me to push B and then pop B. So B, I'm not even going to show that in the final stack. Then it wants me to push C. Now I push C. Then I need to point to the most recent item, which is C. Now that is not done. The last item we still have hanging out is item E. That is how stacks work, and that's how you fill out the diagrams. Hope you guys found this Medley review helpful. If you did, please take a moment and give it a thumbs up to help the channel grow, and we'll see you guys in the next review video.